All right, continuing with vertex form, we're looking at page 92 in your packet. And you've got an equation like this and it says to graph it. And you might think, where the heck do I begin? This thing looks like a mess. That's not a perfect square. It's a negative number. There's no number you could square and get a negative number unless we're talking imaginary numbers, and we haven't even talked about those yet. But we do want to graph this. We want to write it in vertex form. We want to find the vertex, the axis of symmetry, the y-intercept, the x-intercept, and a symmetric point. Okay? So what we have to do here, first of all, this 15, remember, we're always going to look at the quadratic term and the linear term. This thing doesn't complete the square. It's not even a perfect square. So we're going to move it over. Y equals negative 4x squared plus 16x. I'm not changing the sign. I'm keeping it on the same side of the equation. I'm just moving it over. Okay. Now I want to complete the square. The problem is, and we haven't seen this a whole lot yet, but if there's a coefficient on your quadratic term, you just want to factor that out. Now don't factor it out all three terms. This one we've pushed aside. We're going to deal with it later. Just factor it out of the quadratic and the linear terms. So now y equals negative 4. And then we've got x squared plus, we factored that out of here. Actually, we get a minus, don't we? Be careful with that mistake. That's probably the most common mistake. We get minus 4x. And then plus something will complete the square and then bring down the plus 15. Let's just double check that we factored that right. When we multiply it back out, we should get this. So negative 4 times x squared gives us this. Negative 4 times negative 4x gives us plus 16x. That looks good. Now to complete the square, remember what you do. You take the half of this and square it. Half of this is negative 2, square it, positive 4. Now we have to be careful because we just added something to the right side of the equation. We just changed the equation. Okay, did we add 4? Well, yeah, we added 4, but we added 4 inside parentheses that's being multiplied by something else. So in effect, we really added 4 times negative 4. We really added a negative 16, or we subtracted 16. So to counteract that, we either have to subtract 16 from the other side of the equation, but we kind of don't want to deal with that side. Or we can add 16 to this side of the equation. Okay, so just to recap, what we did here when we added this 4, we found the 4 because we took half of this and squared it. But that 4 is being multiplied by a negative 4, so we really added a negative 16 to the right side of the equation. So if we add a negative 16, we also have to add a positive 16, so in effect we added 0. Okay, so now we can write this in vertex form. This is now a perfect square. That's why we call it completing the square. We just completed the perfect square and combine these two. 31. Okay, here's our vertex form equation. Negative 4, x minus 2 squared plus 31. Okay, our vertex is positive 2. Why did I put a 36? That's 31. 31. So positive 2, positive 31. Our axis of symmetry is x equals 2. Okay, x equals the x coordinate of our vertex, or our h. Remember the vertex is h comma k. Remember vertex form. It's y equals a times x minus h squared plus k. So the h is 2, the k is 31, the a is negative 4. Okay, now let's graph this. Okay, so our vertex is 2, 31. How do we want to do this? On the vertex is really high up there. So let's make this go up by, we could just make that. Let's do this. Let's do every 4 is going to be, to get up to 30. So go up by 3s. Let's just go up by 3s. So this is going to be positive 30. We'll make this positive 30, negative 30, and negative 30. You can always change the scale on your graph. Just make sure you designate that somewhere. Okay, so 2 comma 31. And yeah, you can make, maybe we want these to go up by ones. We can do that. We can do that. Sometimes it changes kind of the overall look of your graph, but I'm going to make these go up by ones and these go up by threes. Okay, so now we've got 2 comma 31. So 2 comma 31 would be right here. And when I do that, I'm always going to label 2 comma 31 my points, just not to confuse myself. Okay, let's find our y-intercept. Our y-intercept is our y value when x is 0. So we're going to plug in 0 for x. So we're going to get y equals -4 times x minus 0 squared plus 31, or -4. I'm plugging in 0 for x. So I replace the x with 0. 0 minus 2 squared plus 31. Okay, so that becomes -2 squared is +4 plus 31. So I get -16 plus 31. -16 plus 31 is 15. Okay, so 15, these were going up by threes. 3, 6, 9, 12, 15. My symmetric point is going to be on the other side over here, and that's going to be 4 comma 15, 0 comma 15. Let's find our x-intercepts. Our symmetric point with this is going to be 4 comma 15. And our x-intercepts, well, our x-intercepts happen when y is 0. So let's plug in 0 for y. And I got 0 equals -4 times x minus 2 squared plus 31. I'm going to subtract 31. Divide by -4. Square root both sides. Ugh. Okay, so we get x minus 2 equals plus or minus square root of 31 over 2. So x is going to equal 2 plus or minus square root of 31 over 2. Okay, we can write that all together. 2 plus or minus square root of 31 over 2. Just the 31 is over 2. The 2 is not. So let's make that a little more clear. 2 plus or minus. Now let's make sure these values make sense. How much is 2 plus red 31 over 2 and 2 minus red 31 over 2? I don't know. Let's plug it in the calculator, see what happens. So we've got 2, I'll do plus, control divide. I don't know if you can see that, but that's okay. You can do this on your calculator. Red 31 over 2, control divide. So 4.78, roughly 4.78. So that's about there. I think that makes sense. And then if we do 2 minus, notice what I did there. You can arrow up, and then you can just grab that. So I don't have to rewrite the whole thing, then change that plus to a minus. Make sure you use the minus button, not the negative button underneath the 3. Use the minus that's next to the plus. And then you could do a control enter, it gives you a decimal. So -0.78, yeah, that seems to make sense. Okay, I'm going to label this point. This one is 2 plus rad 31 over 2 comma 0, and this one was 2 minus rad 31 over 2 comma 0. And that's all we needed to do for this one. Notice we didn't do the rapid parabola plotting here. We could have, but this would have been, because these numbers are so weird, it might have been more difficult to do that. Okay. Let's go down to this one on the bottom. This one I think we can do quickly. So y equals x squared plus 5x. We're going to move that minus 24 over. Now to complete the square here, we need half of 5 and square it. So half of 5 is 5 halves. When we square it, we get 25 over 4. We're adding 25 over 4, so now we're going to subtract 25 over 4, so that in effect we just added 0. So y equals, and remember what we do here, x plus. So what this number needs to be, you can look at two things, and it's really nice because you can double check your work. It should be the square root of this, so it should be 5 halves. It should also be half of this number. Okay, so that's your pattern. And it is. It's half of this. It's the square root of this. Squared, then minus 24, minus 25 over 4. So let's get these into common denominators. How many fourths is that? 96 fourths minus 25 fourths. So we've got y equals x plus 5 halves squared minus, what would that be? 121 over 4. Okay, so my vertex is negative 5 halves, negative 121 over 4. Axis of symmetry is x equals negative 5 halves. What is that? I'm just going to do these as decimals because I have to graph them. Negative 2.5, and this would be negative 25, so 30.25. Y-intercept happens when x is 0. So when x is 0, we're going to get y equals 0 plus 5 halves squared minus 121 over 4. Okay, so I'll do that on the calculator. So 5 halves squared minus 121 over 4. Oh, negative 24. The x-intercepts, so that happens when y is 0. So let's find that. So 0 equals x squared plus 5x minus 24. And does that factor? Multiplied in, no, it doesn't factor. Okay, so we're going to have to use the quadratic formula to find this. Actually, you know what? Let's not do that. We just did vertex form, and there's a reason we did vertex form, so this is easier to do. So when the y is 0, we get 0 equals x plus 5 halves squared minus 121 over 4. Okay, so we add this over. 121 over 4 equals x plus 5 halves squared. Square root both sides. That becomes 11 over 2 plus or minus 11 over 2 equals x plus 5 halves. So x equals negative 5 halves plus or minus 11 over 2. Oh, that does factor. We could have factored that. Okay, that would have been easier to factor. But we haven't really gone over factoring yet, so this is okay. So our two numbers are going to be negative 5 halves plus 11 over 2 and negative 5 halves minus 11 over 2. So that's going to be 11 halves minus 5 halves is 6 halves. That's 3. And this would be negative 5 minus 11 is negative 16 over 2. So negative 8. So we get 3 comma 0 and negative 8 comma 0. And let's see how nicely this graphs. Okay. Sorry, you couldn't see that for a second. Okay. Now I think what I'm going to do, since my vertex is at negative 30, I'm going to go up by 3's again on the y-axis. I'm going to go up by 1's on the x-axis. It distorts your graph a little bit, but I think that's we're going to be able to see it best. Okay, so negative 2.5, and then negative 30.25. It's going to be right around here, right about where I wrote this minus 30. Maybe I'll write that on the other side. Negative 2.5, negative 30.25. And then my y-intercept is 0, negative 24. So 3, 6, 9. It should be at 8, right? 8 times 3. Okay. And then this should be at 3, 0 is an x-intercept. And negative 8, 0 is the other x-intercept. Now I'm going to draw my axis of symmetry. It's negative 2.5. And my symmetric point, which should be symmetric. Now notice this y-intercept. I'm going to do the symmetric point with the y-intercept. And it's 2.5 away from this line, because remember this line is at negative 2.5, so it should be 2.5 over, right about there. That should be negative 5 comma negative 24. So negative 5, negative 24. Remember, there's not only one symmetric point. Every point has a symmetric point. Actually, our two x-intercepts are also symmetric points with each other. Okay? So some of these, I think the concepts aren't too bad, but yeah, sometimes the numbers get a little bit messy. Okay, but it's always nice when you graph it and you can see your nice parabola. If you get numbers, sometimes you get a point that doesn't make sense, a point way over here, and you know you did something wrong. So that's always kind of nice. You can go back and find your mistake. Okay, and you can always graph these on the calculator to double check your work. And see you all next time.